Hello guys, welcome back to today's class where we'll be looking at another example on the inverse elements. Now in this example we have an operation giving us x operation y, which is equals to xy plus 1 times x minus x squared. And then we are given for xy, for x and y as elements of the set R of real numbers. And then we are asked to determine the inverse element of minus 2. We have to find the inverse element of minus 2. Recall for inverse elements, we know that x operation, the inverse element always gives us the identity element. So for identity element then, where the identity element, in order to get the identity element, we say x operation E gives us x. So to get the identity element, we say what? If this is x operation E, then from the formula, we can say this is xe plus 1 times x minus x squared, which is then equals to x. So I can simplify this in order to get my E, so I can get my identity element. I'll say this is x squared E minus is x squared E minus x cubed E plus x minus x squared. What I'm doing here is I'm simply opening up the brackets so I can factorize my E by collecting like terms first. I'll have x squared E minus x cubed E equals to x minus x plus x squared. In this case, I'll be getting E into brackets x squared minus x cubed equals to, our x will cancel out each other, and we'll have x squared. Moving on, we'll have our E to be x squared divided by x squared minus x cubed. So we have gotten the identity element, even though that is not what we are going to find finally. This is just a part of the process. But then even the identity element can be expressed in a better form. That is, we can still break this down to say x squared is common here. If we bring out x squared here, we'll be left with 1 minus x, of which we can actually now say x squared, we cancel out this x squared, and then my identity elements will be given as 1 over 1 minus x. So I've gotten my identity elements, but this is not where I'm going to stop. I'm going to go back to my inverse elements. Say for inverse elements, for I now, I remember that was my my x operation I, giving us E, where my E now has been given to me as 1 over 1 minus x. So now I can say what my I here, using the formula, I know we have x y plus 1 times x minus x squared. So in this case we'll be having xi plus 1 bracket x minus x squared equals to 1 over 1 minus x. So in this case, I'll simply divide both sides by this in order to get my I. So I'll just have xi plus 1 equals to 1 over 1 minus x times x minus x squared. What have I done here? I've simply taken my x minus, I've divided both sides by x minus x squared. From here, I can say my xi is basically 1 over 1 minus x times x minus x squared minus 1. I can break this down to say this is This is 1 minus x into bracket x minus x squared. And then I have 1 minus x times x minus x squared. Expanding this will give me, I'll be having I into bracket 1 minus x squared minus x squared plus x cubed by expansion. And then I'll be having divided by, so my x here has come to this side, I'll be having x into bracket 1 minus x times x minus x squared. From here I can see my I here is giving us 1 minus x plus 2x squared minus x cubed all over x into brackets x. Opening this bracket, I have minus x squared plus x cubed. And then I'll have 1 minus x plus 2x squared minus x cubed all over x squared minus x cubed plus x raised to power 4. So we know I'll be having minus 2x cubed here rather. And then from here, I can now see my identity element is, my inverse element now is this. And I see where I is 2, I is minus 2, I mean, where x is minus 2, where x is minus 2, then I now will be what? Will be 1 minus 2 plus 2 times minus 2 square minus 2 cube all over minus 2 square minus 2 times minus 2 cube plus minus 2 raised to power 4. The value here becomes 1 plus 2 plus 2 into bracket 4 minus 8 all over 4 minus 2 into bracket minus 8 plus 16. My I here becomes 1 plus 2 plus 8 all over 4 plus 16 plus 16. Giving my I a total value of 19 over 36. And this therefore becomes my inverse element of minus 2 of the operation asterisk. So this is what we call it a day as regards the properties or the laws involved in binary operation. In the next class, we'll be looking at diagrams and how we can actually chart these binary operations in tables and in charts. So see you next class. Have a nice day.